Somewhere on a server in Europe, there is a locked file. Inside that file is a date. A small team of scientists believes it may be the date that an American volcano erupts. They wrote that date down, they sealed it with a digital lock that cannot be quietly changed later, and they are refusing to show it to anyone, not to the press, not to the public, not even to the other scientists monitoring the very same volcano. The file stays sealed until after the eruption happens, so that no one can accuse them of adjusting their prediction after the fact. And here is the part that makes this story worth the next 20 minutes of your life. While that file has been sitting sealed, the volcano itself did something almost nobody on the monitoring team expected. It changed, quietly, in a direction that has scientists genuinely puzzled. This is the story of the most closely watched volcano in American waters, the machine built on the bottom of the ocean to listen to it, the year everything was supposed to happen, and the strange silence that arrived instead. If you like real science told straight, without the doom and without the sugar, subscribing to this channel is the easiest way to make sure you're here when this story reaches its ending. And it will reach its ending, possibly this year. Let's start with where this thing actually is, because most Americans have never heard its name, even though it sits closer to the United States than Havana does to Miami. About 300 miles off the coast of Oregon, roughly the same distance as driving from Chicago to St. Louis, the seafloor rises into a broad mountain. Its summit sits under nearly 5,000 feet of cold Pacific water, deep enough to swallow 3.5 Empire State Buildings stacked on top of each other. The mountain is called Axial Seamount, and it is, by a comfortable margin, the most active volcano in the Pacific Northwest. Not Mount St. Helens, not Mount Rainier, this one, a volcano no tourist has ever photographed, sitting in the dark west of Astoria on a crack in the planet called the Juan de Fuca Ridge, where the ocean floor is slowly being pulled apart and new crust is born. Geologists who mapped and dated the lava flows on its summit found evidence of at least 49 separate eruptions in just the last 800 years. Think about what that number means. Since roughly the time the Ming Dynasty took power in China, this one mountain has erupted about once every 15 to 18 years, over and over, like a slow drumbeat under the sea. In the modern instrumented era alone, it has erupted 3 times, in 1998, in 2011, and in 2015. And that is exactly why scientists love it. Because Axial does something almost no volcano on Earth does. It breathes in a pattern you can measure. Here is the mechanism, and I promise it's simple. Beneath the summit sits a reservoir of molten rock. Between eruptions, magma rises from below and slowly refills that reservoir, and as it fills, the entire seafloor above it swells upward, inch by inch, like a chest slowly filling with air. Scientists call it inflation. When the pressure finally exceeds what the rock above can hold, the volcano cracks, magma escapes, lava pours across the seafloor, and the summit deflates, dropping back down as the chest empties. Then the breath begins again. Inhale for years, exhale in days. For most volcanoes on land, watching this breath requires satellites, occasional surveys, expensive expeditions, but Axial is different. And the reason it's different is one of the most remarkable machines the United States has ever built that you've probably never heard of. Starting in the 2010s, the National Science Foundation funded something called the Ocean Observatories Initiative, and its crown jewel is the Regional Cabled Array, operated by the University of Washington. Roughly 660 miles of power and fiber optic cable, about the driving distance from Dallas to El Paso, laid across the seafloor of the Northeast Pacific, feeding electricity and internet to more than 140 scientific instruments, seismometers that feel every tremble, pressure sensors that can detect the seafloor rising or sinking by fractions of an inch, tilt meters, cameras, chemical sniffers parked next to hydrothermal vents. A portion of that cable runs straight up the flanks of Axial Seamount and into its summit crater, which means this volcano, alone among almost all volcanoes on Earth, is wired, live, streaming data back to shore every single second of every single day, Scientists sitting in offices in Oregon and Washington can watch this mountain breathe in real time, the way a cardiologist watches a heart monitor. And in 2015, that monitor caught something extraordinary. To understand what happened, you need to know what came first. Two researchers, Bill Chadwick of Oregon State University and Scott Nooner of the University of North Carolina, Wilmington, had been tracking axial inflation for years. They noticed that the 2011 eruption seemed to trigger when the seafloor swelled back to roughly the same height it had reached before the 1998 eruption, as if the volcano had a fill line, like a mark on the inside of a kettle. So, in September of 2014, at a scientific meeting, they went out on a limb that most volcanologists would never dare walk. They stated publicly that Axial would likely erupt within the calendar year 2015. Understand how rare that is. Volcanology is a field burned so many times by failed predictions that most scientists refuse to give dates at all. These two gave a window, in public, 7 months before anything happened. Then came the night of April 23rd, 2015. The seismometers on the summit began to chatter, then to roar. Earthquakes arrived in swarms, first hundreds, then thousands. By April 24th, the network was recording close to 8,000 earthquakes in a single day. That is roughly one earthquake every 11 seconds, hour after hour, for an entire day. Most were tiny, but the message was unmistakable. Rock was breaking. Magma was on the move, forcing its way into a crack along the volcano's southern rift. And then the pressure sensors delivered the second signal. The center of the summit crater began to sink, fast. Over about 3 days, the seafloor dropped roughly 8 feet. Picture the ceiling of your living room suddenly becoming the height of a kitchen counter. That's how much the top of the mountain deflated as molten rock drained out of the reservoir beneath it. The chest was emptying. The exhale had begun. When research ships finally reached the site months later, they found what the instruments had already told them was there. Fresh lava flows sprawled across the seafloor, one of them more than 400 feet thick in places, a 40-story building of brand new rock that hadn't existed in April. They found hydrothermal vents blasting so much microbial material out of the warm, mineral-rich water that researchers nicknamed them snowblowers, white plumes of life feeding off the volcano's chemistry in total darkness. The eruption had landed inside the forecast window. For the first time in history, a volcanic eruption had been publicly and successfully forecast months in advance, based on a measured, repeating pattern. Champagne moment. Scientific history. Which brings us to the obvious question, and the reason this video exists. If they nailed it in 2015, what does the pattern say now? Well, that's where the story stops being tidy. After 2015, Axial began inhaling again, right on schedule. The seafloor rose. Year after year, the pressure sensors watched the summit swell back toward that fill line. By 2024, the volcano had essentially returned to its pre-2015 height, and the numbers were accelerating. The seafloor at the caldera center was rising at up to 10 inches per year, and there were days when the seismometers logged over 1,000 earthquakes. In December of 2024, Chadwick stood up at the largest earth science conference in the world and delivered the sentence that launched 1,000 headlines. Axial Seamount appeared likely to erupt before the end of 2025. The media response was, frankly, a phenomenon in itself. Wave after wave of coverage rolled through 2025. National networks, major newspapers, even celebrity magazines, often recycling the same facts months apart as if something new had happened. Some coverage was excellent. Some was cartoonish, with headlines screaming that the volcano was about to blow, illustrated with images of explosions bursting out of the ocean, something Axial is physically incapable of producing, and we'll get to why later, because it matters. Meanwhile, out at the volcano, something subtle was going on. The scientists kept waiting for the tell. Before the 2015 eruption, the earthquake count had climbed relentlessly, reaching more than 2,000 per day and staying there for months. One quake every 40 seconds or so, around the clock. Deborah Kelly, the University of Washington professor who directs the cabled observatory, said plainly that if the 2015 playbook held, she'd expect to see more than 2,000 earthquakes a day for a few months before the next eruption. Instead, through most of 2025, the counts wobbled around 100 to 300 a day, about 4 to 12 an hour. There were occasional spikes. One day in the summer topped 2,000 events, and the tsunami from the massive magnitude 8.8 Kamchatka earthquake on the far side of the Pacific actually swept over Axial and tripped the automatic eruption alarms 6.5 hours after the fault ruptured in Russia, a false alarm that showed just how sensitive this network really is. But the sustained, months-long crescendo, it never came. December 31st, 2025 arrived, and the volcano had not erupted. The forecast had failed. And, to their enormous credit, the scientists said so, in public, in writing, without excuses. Chadwick openly acknowledged that every forecast he'd made since 2015 had been wrong, that the team had repeatedly moved the goalposts, and that if you keep pushing a prediction forward forever, eventually being right proves nothing. I want to pause on that for a second, because in an era where nobody admits error, there is something quietly heroic about a scientist keeping a public diary of his own failed predictions and explaining exactly why each one broke. By the way, if something in this story has surprised you so far, tell me what it was in the comments. I read them, and it genuinely shapes what this channel covers next. Now we arrive at 2026, the year of the new forecast, and the year of the change. The revised prediction, presented at that same December conference, rests on a clever new idea. Instead of just asking how high the seafloor has swelled, the team looked at the relationship between swelling and shaking. Their records show that as Axial inflates, the number of earthquakes per inch of uplift doesn't grow steadily. It grows exponentially, slowly at first, then faster and faster as the rock gets closer to breaking. Before the 2015 eruption, that ratio climbed to an extreme level, roughly 10,000 earthquakes for every half inch or so of uplift, and it stayed pinned there for the final 3 months. The hypothesis is that this ratio is the volcano's true tripwire, the sign that the rock has stopped stretching quietly and started genuinely failing. Working the math forward, the team estimated they'd need to see the daily earthquake count climb to around 500 per day at current uplift rates, and they projected that threshold would arrive before the end of 2026. So the entire monitoring community leaned in, waiting for the earthquake numbers to rise. They fell. Starting around January of 2026, the pressure sensors recorded something that nobody's forecast had called for. The inflation slowed to roughly half its previous rate. For stretches after mid-January, the uplift line on the plots ran almost flat. The volcano, which had spent 2 years rising about as fast as human hair grows, nearly stopped rising at all. The earthquakes followed. Through late winter and spring, most days logged fewer than 100 quakes, with only occasional bursts of a few hundred. The scientists, with characteristic honesty, described the volcano as taking a spring break and admitted the words that matter most in this entire story. What is causing this? We don't know. Sit in that uncertainty with them for a moment, because it's the honest heart of this video. A fully inflated volcano, standing at or above the height that triggered its last 3 eruptions, at the peak of a forecast window, suddenly easing off the accelerator. Is the magma supply from below genuinely waning, delaying everything by years? Is the reservoir quietly rearranging itself in a way the sensors on the surface can't fully see? Or is this the deceptive stillness some volcanic systems show late in the cycle, a lull that means nothing about what next month holds? Every one of those readings is on the table. The data doesn't yet say which. By May, there were hints of the volcano perking back up, the short-term uplift rate ticking modestly upward again, while the longer average kept sagging. Up and down, the way this mountain has teased its observers for a decade. "Nothing imminent," the researchers wrote. And that phrase, "nothing imminent," has now outlived 3 separate waves of national headlines claiming the opposite, which is exactly why the sealed file in Europe matters so much. In November of 2025, 2 scientists outside the Axial team, Qinghua Lei of Uppsala University in Sweden and Didier Sornet of the Swiss Federal Institute of Technology in Zurich, launched what may be the most rigorously honest experiment in the history of eruption forecasting. They had developed a physics-based mathematical model of how materials fail, the same underlying mathematics that describes a landslide letting go, a glacier calving, a mine wall bursting. Applied to old axial data after the fact, the model could find the failure point. But after the fact is easy. Hindsight is where forecasting goes to cheat. So they removed the ability to cheat. Since November, they've been feeding the live data from the cabled observatory, the uplift, and the earthquakes into their model and producing a fresh eruption forecast roughly every month. Each forecast is locked with a cryptographic seal, a mathematical fingerprint that proves the document existed on a specific date and hasn't been altered since. The forecast dates themselves stay hidden until after Axial erupts. Then, and only then, every forecast gets published, the successes and the failures alike, so the world can judge the model with no possibility of quiet revisions. Releases have already been sealed month after month through the winter and spring of 2026. Somewhere in those locked files is a date or a series of dates. Nobody watching the volcano knows what they say. I'll be honest with you, this is the detail that stopped me cold while researching this. We are watching a live competition between human pattern recognition and pure physics, run against a volcano that has humbled every forecaster who's approached it, with the answer key locked in a vault that opens only when the mountain itself decides to grade the exam. But in June of 2026, this entire experiment, the whole grand project of listening to the sea, very nearly lost its ears. In late May, the federal government announced a major descoping of the Ocean Observatories Initiative, the program that funds the entire network. Under the plan, the ocean monitoring arrays that this system operates around the globe would be discontinued and dismantled. The cabled array watching Axial was granted a partial reprieve. It would keep operating, but only through September of 2028, with everything beyond that date left blank. The story hit the front pages of major national newspapers in early June. Scientists across the Pacific Northwest described being stunned. Decades of continuous, irreplaceable ocean data, the heartbeat monitor on America's most active volcano among them, facing an expiration date. What happened next is worth remembering the next time you feel cynical about how things work. Lawmakers from both parties pushed back hard. Oregon's senior senator led a congressional effort to stop the dismantling of the nearly $400 million system. Coastal communities, researchers, and universities made the case publicly for what would be lost. And on June 18, 2026, barely a month ago as I record this, the decision was reversed. The ocean monitoring system will not be dismantled. The instruments stay on. The data keeps flowing. Think about the timing. If that reversal hadn't happened, we could have been facing a scenario where the best instrumented volcano on Earth approached its most scientifically valuable moment in a decade, just as the budget clock threatened its future. Instead, the stethoscope stays on the patient, for now. Now, let's do the part this channel never skips, because you deserve the truth without the costume. If you've seen headlines about this volcano, you've probably absorbed some fear that doesn't belong to you. Let's give it back. First, when Axial erupts, and it will, you will not see it, hear it, or feel it. The summit lies under nearly a mile of ocean. At that depth, the weight of the water above presses down with such force that the explosive style of eruption you picture from movies is physically impossible. The gases that drive violent explosions stay dissolved, squeezed into the melt. Lava at Axial doesn't blast. It oozes, forming rounded pillow shapes as seawater instantly chills its skin. The 2015 eruption, one of the larger ones in its modern record, produced no wave at the surface, no shaking on shore, no sign whatsoever that any person standing on an Oregon beach could have detected. The only witnesses were machines. Second, an axial eruption will not send a tsunami at the west coast. Tsunamis of consequence come from huge vertical shoves of the ocean floor across vast areas, or from massive collapses. Axial eruptions are gentle in exactly the way that matters. The seafloor sags a few feet over days as the reservoir drains, rather than heaving upward in seconds. Third, and this is the one I most want to land, because I've seen this claim spreading. Axial Seamount is not connected to the Cascadia subduction zone in the way the fear merchants imply. Yes, both sit off the Pacific Northwest. But Cascadia, the fault capable of a catastrophic magnitude 9 earthquake, is a separate system over 200 miles closer to shore, where one tectonic plate dives beneath another. Axial sits far out on the spreading ridge, where plates pull apart. There is no scientific evidence that an eruption at Axial can trigger the Cascadia fault. None of its 3 modern eruptions did anything of the sort. Anyone stitching these two systems together into a single doomsday chain is selling you a cartoon, and the honest version of this story doesn't need it. Cascadia deserves your preparation. An earthquake kit, a family plan, secured water heaters, because Cascadia is real and its risk stands entirely on its own. Eruption or no eruption. Axial deserves your fascination. Those are 2 different emotions, and you're allowed to hold both. So, if it can't hurt anyone, why does this dark mountain deserve 20 minutes of your attention and millions of dollars of instruments? Because Axial is the practice field for a skill humanity desperately needs and does not yet have. Roughly 800 million people on this planet live within reach of active volcanoes, near Naples, near Mexico City, across Indonesia, the Philippines, Japan, and yes, in the Pacific Northwest beneath the Cascade Peaks. For those volcanoes, a reliable forecast weeks or months ahead would be the difference between orderly evacuation and catastrophe. But you cannot run forecasting experiments on Vesuvius. Get it wrong in either direction, and you either kill people or trigger a pointless evacuation of 1 million residents that destroys trust for a generation. Axial is the one place on Earth where scientists can make bold public predictions, fail, say so, adjust, and try again with 0 human cost. It erupts frequently. It's wired better than any volcano in existence, and nobody lives there. Every failed forecast chronicled in this video is not an embarrassment, it's tuition. The lessons being paid for here: how magma supply speeds up and slows down, how earthquake ratios reveal rock approaching failure, whether pure physics can beat pattern matching, will one day be applied to volcanoes where the stakes are measured in lives. When a forecast model someday tells the residents of some city on the far side of the world to leave 3 weeks before their mountain explodes, part of that model's confidence will trace back to a dark seamount off Oregon that spent decades teaching scientists how to be wrong correctly. There's one more small, human detail I can't leave out. In April of 2025, at an open house at the Marine Science Center in Newport, Oregon, 84 ordinary visitors, kids, retirees, families, were invited to write down their personal guesses for when Axial would erupt. Their guesses ranged from that very afternoon all the way out to November 27th, 2026. Somewhere in that stack of index cards, some kid may have already beaten the best models in the world. The volcano will decide. So here is your watch list. The specific signals that will tell you the next chapter has begun before any headline does. Watch the earthquake counts. The daily numbers are public, updated continuously from the seafloor network. The magic number from the current forecast is around 500 earthquakes per day, sustained, not a one-day spike. If counts climb toward that level and hold, the tripwire hypothesis is being tested in real time. If they surge past 2,000 a day for weeks, the 2015 playbook is repeating, and an eruption may be close. Watch the inflation. If the current lull ends and the seafloor resumes rising at the rate seen in 2024, the timeline tightens. If the flat line continues deep into the fall, expect the scientists to do what they've always done, publicly extend the forecast, and expect a fresh round of headlines pretending that's news. Watch for the day itself. When the eruption comes, it will announce itself in hours. A seismic storm, a plummeting pressure reading as the summit deflates, alarms in offices in Oregon and Washington in the middle of some unremarkable night. And then, days or weeks later, the sealed files in Europe will open and we will learn whether physics saw it coming. The current forecast says before the end of 2026. The forecasters themselves say openly that they've been wrong every time since 2015, and they might be wrong again. That combination of ambition and humility is exactly why this story is worth following to its end. The mountain has been holding its breath since 2015. 11 years of slow inhale, now strangely paused, chest full, silent, 300 miles off the American coast, in water black as space. Every previous breath has ended the same way. I'll be watching the data when the exhale starts, and I'll break down exactly what happened, what the models got right, and what the sealed forecast said, right here. If you want to already understand what you're looking at when that day comes, now you do. And if you want to be here for it, you know what to do. The next reading from the bottom of the Pacific is already on its way up the cable.